what are the Lightning Web Component and its web stack, how we transform from the Aura and to the LWC stage. And we do have some templates and slots and shadow domes, custom elements, and everything in LWC. I will be giving the overview about that and a short demo on how to use the LWC and with some examples. And next is about the life cycle. And we do have the data services in LWC. So let me go with the LWC. So what are the Lightning Web Components? So as we know that LWC is a new programming language. It's not very new because it was introduced in 2019, and so people started using implementing the components in LWC instead of Aura. So because they have introduced the LWC with the new framework, and this model is architected like with some principles, considering that it should match with the modern web standards, and it should also give for the better performance, and it is easy to use because since LWC uses the modern web standards, so everyone can whoever learns the web standards can jump to the LWC, and everyone will understand, and it is easy to use. And the interoperability, nothing but the compatibility with the Aura components. So Aura based Lightning model is the native to the Salesforce, and LWC is the native to the web standards. So they have kept these principles while implementing the LWC. And let me go here. Okay, so coming to the modern web standards. So as we know, like so for each web standards, like World Wide Web console systems. So they will define some standards to use, what should be run in the worldwide, web, and what are its principles, and what are the constraints that we have to use in the web browsers. And coming to the LWC framework. So let me go to the web stack transformation. And if you see on the left part, web stack is of 2014, and the center one is the 2019 web stack. So if you see on the left part, where in blue color, so those are the web standards, and at the top, those are the frameworks. So web standards is nothing but LWC was not introduced earlier because we have a very limited web standards, which is ES5 version, some standard elements, and some rendering components. But if you see on the top part, these frameworks are not there in the web standards, where a lot of features are missing, like data services, UI components, and optimization modules, language extensions, and etc. So these are not capable enough to implement the LWC, and that's where we do have the many different other languages which was built earlier, like React, Node.js, Angular, where they have considered all these features into their framework. So and even Salesforce has introduced its own framework called Aura framework, which is native to only the Salesforce. And so if you see on the web stack 2019, where LWC was introduced, and they were introduced based on the considering all the web standards. It has built on the top of these web standards. So if you see, most of the features are covered in the web standards web stack. So comparing to the 2014 and 2019, so whatever we are seeing in the red box here, so most of the features are covered in the web standards in 2019. And if we see on the top, so these features are missing in 2019, which is nothing but the data service, UI components, and specified services. So in the LWC, they have introduced our Lightning Web Component with these same web standards, along with some additional features, which are security with the Lightning Logo service, and just for the better security. And they have introduced the LDS, Lightning Data Service, and they also introduced the base Lightning components. So, and whatever the security part, it means just for the less vulnerabilities and all. And we do have the Lightning Data Service, and which means it is a native in the Salesforce, where we do have in the Aura component as well. So which means without writing the Apex calls and the security inheritance, considering all the scopes, they have implemented the Lightning Data Service, and the same feature is available in the LWC framework. These three. And base Lightning components, all the 75 base components are converted to LWC, which is available in Aura, so that we can use the same Lightning tags here as well. So that's where, keeping in the mind of all the web standards, they have built the LWC. And LWC is a reusability. We can create one template, and we can import or export those templates, and it will allow us to reuse all the components in the different application or same application with the help of events and all. And it also have the encapsulations, and which will use the shadow DOM. So the DOM is the major part which plays in the browser level in the tree structure. Okay. Let me, these are very important factors that to run the framework, like the components and templates, and the custom elements, shadow DOM, modules, and ES7. ES7 is nothing but it's a JavaScript version. And the Lightning Web Components runs only after the version 46 and beyond. So before 46, it won't run the LWC components. And we do have the standard elements and rendering components. So coming to the templates and slots, this is these are one of the standards in the web component framework. And the templates allows us to load HTML tags without rendering them on the initial load. So in the HTML part, we do have the multiple templates, and so it won't render on the initial load when the JavaScript writes the web page, but we should define when it should load and when it should render. So we do have the control for all the templates, and same goes with the slots. And we can reuse this component, like where we can create a multiple HTML files, and where we are using those templates, and we can call one page in another page. And it is attached to the shadow DOM or DOM. So in the DOM tree, we do have the shadow DOM, which plays which is a super advantage of the LWC. I will be explaining that in the next slide. And the slots are just the placeholders, and that allows us to add some markup in that slot, which will it is capable of reusability in the same slot. And shadow DOM. So in the web browser, the shadow DOM allows the web browser to render DOM elements. So a Lightning Web Component runs on the client side, which means on the browser level, So browser knows everything, whatever the standard elements that we are using. So we don't need to tell to the browser that, we don't need to define any additional things unless only the framework part. So, and it writes the shadow DOM, and the browser will understand in which level, in which level it should render.
There is one question
Yeah.
from Prashant Salyan.
Yeah, yes.
So maybe
he's asking about the slots in.
Yeah.
So 1 second. I was always curious about slots. Is there any real life scenario in which we can use the slots? Yes. So the slot is just a markup, and we can include anywhere in the HTML or in the template, and it is just a placeholder. And so if you are passing if you want to pass some data to the from the parent to its component, and let me show that in the real time in the demo part.
Sir, thank you.
And yeah. So so whenever Shadow DOM will be it will be the super useful when we are implementing the LWC with third-party libraries. So these elements will render under the Shadow DOM, and which will use its native API in the JavaScript. And for each framework, it has its own lifecycle methods. And for the LWC, we do have the lifecycle method, and which will responsible for each stage. And so these are the stages, and that is constructor, connected callback, disconnected callback, rendered callback, and error callback. So these lifecycle plays on each component. So whenever each component is loaded, or whenever we are seeing the UI screen, so these all actions will be compiled in the browser. So I will show in the real use case scenario how it is actually works and how it will render. And so these are the data services and lightning data services. So as we know, we do have the two types of data services. One is the lightning, standard lightning web component, which will provide the lightning record edit form, a record form, and record view form. And in the lightning UI APIs, which will bind with the server calls, which uses the UI record API and UI object API. So I will just go to the browser. So we can't use we can't implement the LWC code in the native IDE, which is the developer console of Salesforce. We do have the different tools where we can build the LWC using the SFDX. So I'm using the VS Code or IntelliJ or any other IDEs is one which supports the SFDX. Okay, so we do have the official document which was released by Salesforce for LWC, and it explains the each and everything, include from the beginning of creating the component, on how to install the SFDX and everything. So okay, let me jump over to the VS Code, and so I have installed some extensions. One of them is the Salesforce extension pack, and, which will we can able to create from the US side, or and the native part is to run from the CLI to create the project or to execute any commands. So we can do it from the CLI, and another way is to do from the extension part. So first, I will create a project, and we have to name the project.
Sorry to interrupt you, Sunil. I think your screen
Yeah.
is not visible. We are still seeing the presentation.
1 second. I'll just stop sharing and I will share the screen.
Okay.
Can you see the Visual Code editor?
Yes, we can see.
So we have to name the project for this, and it can be anything. So if you see, I have just gone to the UI screen, and I just clicked on the create project button, and so we can see one folder structure level here. It is a Salesforce folder structure, and so in the Force app, inside the Force we do have the main. Inside main, in the default, we can see the LWC here. So all the LWC web components will be reside under the LWC. And if I go here and I can create the Lightning web component. So these are the default code that we comes with the while creation. And if you see, this is my name, and it comes with the HTML, JavaScript, and XML. So this is the mandatory part, XML and JavaScript. And what are the configuration that we can do for this LWC component can be done in a XML file of this component. So we can see all the API versions, and we can add all the different tags to work for the different scenarios. Like this component should be available to mobile. Then we have to define the scope here. So these are the default tags that comes, and if you want to expose this component, and it should be the true here. So as I said, it runs on the web standards. So a template is one of them. And if you see, so inside template, we can write as many elements as we want. So that's how the web standard works. And I can include any markup inside the template, and I can just run this. So some issue with my local div. So this is the folder structure, and the same we can implement in the browser as well. So it is still in beta. So we can just navigate to the web components.dev. So if anyone want to get started with the LWC, they can just go here and select the LWC. So here we can't see the full structure, but inside the source, we can just see the HTML, JS. Sorry, it is already the predefined, and we can still create a new component. And okay. Just a second. I will just delete the child component, which is mandatory for the existing ones. So So if you see, this is the native that I'm showing earlier, which is nothing but the template. And inside template, we can wrap as many as elements as we want. And we don't need to worry about all these things. Inside, we can just include the markup, and once it is saved, we can able to see the rendered part here. So here we are using we are seeing the input part, and so from the LWC. So as soon as we created the project, it will load with its own library. Nothing but no, it is already configured. In its project JSON files. So once we are able to import the lightning element from the LWC. So once we are importing, so we have to extend by using the export class. So these import and export is of the web standard native full stack web stack of 2019, which is nothing but ES6, and it's beyond the versions.